Thanks, everyone. And thanks to FirstMark for having me. I did some research. I think I am the first Mark to speak at FirstMark for Code Driven, so pretty proud of that. I'm going to talk about the Elm programming language. You can follow me on Twitter at Wunsch. I usually tweet out kind of links. I'll tweet out links to the slide deck when I'm done, so shoot me a toot. Going from Chris, like low level, I'm going to go way up there now, so should be cool. Cool. So I'm the director of engineering at Harry's, which means I am a middle manager. I don't do a lot of coding as part of my sort of day-to-day job. So what I started to do a couple of years ago is try to write some code out in the open every weekday. And I don't go crazy about it. I take vacations, take breaks occasionally, but I just do it as a way to keep my technical skills like sharp. I write about the code that I've written in the previous week in a newsletter that you can subscribe to, and this talk comes out of that experience. So I spent about 6 months or so learning and writing in the Elm programming language. I wrote a game in Elm, and so I wrote about that experience along the way, and this talk sort of comes out of that experience. So this description comes from the Elm website. The emphasis is mine, a delightful language for reliable web apps. And so what I want to talk about is what makes a web application reliable and what makes a programming language able to write a web app more reliably than another set of tools. Generate JavaScript with no runtime exceptions. Like that's a pretty bold claim. So this is a talk about writing web applications, so front-end engineers will probably get more out of this talk. I think when learning a new language or a new framework, it's really helpful for me to think about the theory behind it. Where does this thing come from? Why is it built this way? What trade-offs is it making? Who made this thing? All of that stuff. So the first thing I'm going to talk about is kind of the history of Elm and locate it kind of amongst similar tool sets. And what about its design lends it to this reliability aspect. So that's the theory part. And then I'll talk about using Elm in practice, how to actually apply it, and what I used it for, the game I wrote, give you a fast introduction to Elm. And then I'll close by talking about why anyone ought to consider Elm for their next project. So first, let's talk about the theory. So I'm going to talk about papers. I'm a self-taught programmer. As practitioners, I think it's very important for us to have a tether to the academic research that informs the work that we do. So before I get too deep into it, I just wanted to shout out another meetup, which is the Papers We Love community. So this is a global meetup. There's meetups all over the world. There's a really active community in New York, all about sort of reading, understanding research papers for computer science. So when we ask where does Elm come from, so it comes from academic research. So this is the 2012 thesis by Evan Czaplicki, the creator of Elm. Elm concurrent FRP for functional GUIs. This was his thesis at Harvard. So he describes Elm having two major features. Purely functional graphical layout, which I'll actually talk a little bit more later when we talk about the practice part. I want to focus on the second thing, which is support for concurrent FRP. So of course, yes, concurrent FRP. This is not a widely known acronym, so I'm actually just going to gloss over it. We'll define it in just a second. So concurrent FRP solves some of FRP's efficiency problems. We're just going to keep on moving, keep it going. So global delays and needless recomputation. And needless recomputation is the thing I really want to kind of focus in on here. So for some of the front-end engineers in the room, this should stick out. So why should we recompute a function when the input hasn't changed? And this should strike a chord with folks who have been exposed to React. So part of React's whole thing is this idea that you should only compute or render something when the state of that thing has changed. So React and Elm share this common kind of ancestry and ideology. So they're two implementations of really the same premise. So people talk a lot about how fractured modern web development is, but I think what's interesting is so many of these ideas kind of emerged out of the same principles. They're just different implementations of the same things. And even the timing is similar. So React, the initial release was May of 2013. That's 1 year after that thesis was written. So all of these kind of inspired by and involved out of this subfield. So this is what that FRP thing is, functional reactive programming, which was first written about in this paper, which is celebrating its 20-year anniversary, functional reactive animation from Microsoft Research. So Microsoft created another web framework, web tools called reactive extensions that are used in .NET. There's a reactive extension for Cocoa, for JavaScript, all of those things. So you see in both academia and in research and in industry, Microsoft, Facebook, Harvard, all of these sort of converging ideas all around the same sort of thing. So back in the Elm thesis, so FRP recasts mutable values as time-varying values. So it acknowledges that there's this temporal aspect to state. So state changes with respect to time. So we're going to reify time as an entity of our system. And that's what FRP is really all about. So this is like a type annotation, right? This says that a signal of type alpha is a function that takes a time value, some kind of causal event, and returns an alpha. And so this is really FRP's premise. Time is a first-class citizen with respect to program state. So a signal represents state that can vary with time. So when we say what makes Elm reliable, it's kind of built on this idea of concurrency as this first-class kind of entity. So time is all about the concurrency is the interleaving of time in a system. And so concurrent FRP, as implemented by Elm, is all about enforcing a strict ordering of events with respect to state. So state changes are forced to occur in a managed sequential manner. So you restrict the flow of state changes. Restrict the flow of state changes. This should feel familiar if you have ever encountered Redux.js, which is like real popular stuff now. We use Redux at Harry's. I used it at my previous job at Rent the Runway. You'll see Redux paired with React a whole lot. It's seeing really wide use. And it describes itself as a predictable state container. So this idea that there's this enforced consistency for state changes. So again, these ideas, they're all kind of called something different. They all have different terminology, but they've all sort of emerged together to sort of form this sort of premise. And then they've converged. So last year, this blog post came out, written by the author of Elm, and they just threw away all of this FRP terminology. So I've just spent all this time talking about FRP, and now we're just going to put it to the side. Because I think the web application sort of development tool set is converging on simpler abstractions. So from that blog post, so talking about the academic underpinnings of FRP and Elm's place amongst like emerging implementations, and now it's like just a friendly functional programming language, right? But that's a good thing. It is friendly, and I'll talk about those like friendly qualities specifically. But ultimately, Elm is pleasant to use. So let's put it into practice. So we have this FRP legacy. It's not FRP anymore. So what does it mean? Let's just make an app. So with FRP out, what's come to replace that is what Elm calls the Elm Architecture. And so you'll see this a lot when you're looking at Elm. It kind of goes hand in hand with the Elm programming language. You can't really do anything in the language without implementing this architecture. And so it's this sort of model, update, view kind of paradigm. So let's look at some code. Here it is. So here is just a little bit more than the basics of what you need to write an Elm program. So right, it's boilerplate. Don't be afraid. This is like just a bit more than hello world. I'll be sort of filling it more. But what I want to do is introduce you to the syntax, because it can be really daunting if you've never seen an ML or a Haskell style language before. So we're going to kind of just burn through it. If you want to sort of take a look at this, check out this gist. I'll tweet this out later. You could just go to my public gists on GitHub if you'd like to. OK, so we're going to power through some syntax as fast as possible, just like cold water. So we're creating a module called main, and we're exposing all of the functions publicly as part of its public API. So that's what that parentheses dot dot is. The little dashes, those are code comments. We're importing the HTML module. We're pulling everything in from the HTML module, all of these functions. Elm is a functional programming language. There's just functions. Cool. So this is the main function. So similar to C, Java, there's a main function. That's like the main entry point. So this top line here is our type annotation for the main function. Not needed. Elm has type inference, but it's nice to have. So main is a program. Forget sort of what it's parameterized with for now. So we're saying the main function, we're going to implement this HTML.program. This isn't like object field lookup or method lookup. This is like, I want the program function out of the HTML module. And we're going to pass it an argument, which is in the squiggly braces here. This looks like a JavaScript object, but it's a Elm record. So they're similar. But the fields on the left are fields of that record. And then on the right are functions in my program that are named the same thing. And so this is sort of all the wiring that Elm does to sort of hook up its plumbing. There's a model. So type alias. This is a record. It's an empty record. Type alias is just a way of assigning a convenient shorthand to a type. There's a init, which is my initial state of the application. So in parentheses here, this is a pair or a tuple of my model and this command message. So Elm has what's called managed effects. So in programming, we deal with side effects all the time. In a JavaScript program, you can do whatever you want at any point of time. You can call out to an AJAX service. You can like call into some function that you don't know about. That can have side effects. Elm does not allow you to do those things. Instead, you're forced by the type system to sort of go through this command thing. So the initial state of your application is your initial model and then a command to run. And this command pushes something down into the runtime, and then Elm will sort of deal with the rest of that. Once again, command none, that's not a function, like a method call, it's function lookup. Cool. All right, update. So we have our model. We're going to update the model. So we have this type message. So Elm has union types or sum types or algebraic data types, whatever you'd like to call them. I'll get into that in just a little bit. We have an update that takes a message, which is like, think of this in Redux as similar to an action. So a message and a model. So this takes two arguments and returns a third. Elm, like Haskell, has automatic currying. It's going to return a new updated model and then potentially a command to run. In this case, I'm not really doing anything. I'm just returning the model and not doing anything afterwards. There's subscriptions. So command sends stuff down to the runtime. Subscriptions are how you get stuff back out of the runtime. So examples of subscriptions are input that you would get from a user. So things like mouse movements, keyboard input, things like that. Window resizing. I'm not really going to use it during this talk, but you can think of those two things, the command and subscriptions, as being like corollaries. OK, here's that purely functional graphical layout we were talking about. So our view takes a model and returns some HTML. It's a pure function over the model. Cool. So let's do something with the model. I'm going to add a string field called greeting to the record, and I'm going to set it on init. There it is. And then in my view, I'm going to render it. OK? And then we render it. Yay, hello world. We did it. OK, cool. That's a program. OK, fine. I want to show you the compiler, which is like one of the best parts of Elm. So I put in a typo. So in a JavaScript program, remember Elm said like there's no runtime errors? So this is the most common source of runtime errors in my experience in JavaScript programs, is like a dumb typo that you put somewhere. And Elm won't let us do this. And this is why these record kind of things are really powerful, much more powerful than JavaScript objects. So if I try to compile this, Elm is going to say like, hey, this type doesn't match. You told me I was going to get a model, but instead you gave me this other thing. Oh, by the way, looks like you made a typo. So when Elm says it's a friendly functional language, it's really friendly. The compiler is friendly and says, hey, you made a typo. You want to fix that. I've never, you're not going to get that in IntelliJ, right? So one of the things that you should do when you're doing Elm development is just like lean into the compiler. Because you just compile. If it doesn't compile, fix it and move on. And it's very nice to you. Cool. OK, so how am I actually using it? I said all this stuff about like time and state and time together. And let's actually do something with that. So randomness is a good example of state that changes with respect to time. Because it could be anything, any kind of input. So maybe you might not suspect this about me, but I enjoy a game of chance. I'm talking, of course, about Dungeons and Dragons. So I'm going to add a button. And when you hit the button, I'm going to roll a 20-sided dice. And I'm going to show the result of that roll. Cool. So first, import some modules we need. The random module, some other HTML stuff. I'm going to add a dice roll sort of field to our state, initialize it at 0. I'm going to update our message type with 2 types of message. So there's a button click and a roll. So when you click the button, it's going to trigger this sort of button click kind of update action. And then roll is going to update the model with that new roll. And here's the view. It's purely functional graphical layout. We add a button, and on click, we say button click. And that's why this HTML return type is parameterized with our message type. Cool. Finally, in our update call, I'm going to pattern match on the message. Elm has pattern matching, which is great. So when the button click comes in, I'm going to instruct Elm with a command. I'm going to say generate a random integer between 1 and 20, and pass that to the roll command. And then when I get that result, I'm going to do some stuff and show it on the screen. Update the model. By the way, Elm handles all of the plumbing. I don't call the update function anywhere in my program. Elm just has it wired up. So I don't even think about that. OK, here it is. Yay, just keep pressing that button. If we get a 20, it's going to say something special because it's a crit, because it's a 20-sided die. So let's see if that happens for us. Yay, all right, cool. So thing to pay attention to is this little thing down here. See that? Because of the strict ordering of events with respect to state, we can actually explore the full history of this application state. This is the time-traveling debugger. So you can explore the history and see how the state has changed over time. And so I can sort of go backwards in time. Because we've generated random numbers in a purely functional way, I can sort of see those previous results. You can inspect the model here and see how that state has changed. I can import or export histories to my application. Hugely powerful. So now we have all of the pieces in place to create a game. And here's the game that I built. It's called Hive City. Right? Doesn't look like Overwatch or World of Warcraft, right? Yeah, that was like the game I was addicted to too. It's like my one thing that I know about. But I'd never made a game before, and I wanted to start with the basic building blocks. So in this case, I modeled the game after Warhammer 40,000. Any? Yeah, no, I wouldn't expect. Oh, one, yeah, there's always one. Okay, that's another dice-based game. So what I'm doing is I'm controlling the blue characters on this sort of game board. I can move them around. I can roll some dice, and if the dice roll is like above a certain number, it makes like a shooting attack. Right? It's fun. So this is Hive City. You know, might not look like much, but it's a game. Okay, so at this point, you should have enough to at least get started with Elm and an understanding of what you can build. So the hard part is like what you build, and I can't help you with that. But I can sort of point you in some interesting directions, which is you can really easily integrate Elm with any other JavaScript app, especially another React app. So there's this integration with React, so you can just pull in Elm into your existing React application. There's a blog post there about how to do that. It's called How to Use Elm at Work. So, why would you want to do this? Why would you want to use Elm? So I'm going to just sort of sat through 3 talks. So like, here's one more to sit through. This is a talk called Let's Be Mainstream by the creator of Elm. I think it's a fantastic talk that really outlines what Elm is about. It's a purely functional, statically typed programming language. Who cares? What does that actually buy you as a developer? And we use terms in engineering like it's safe and it's easy to reason about. But that doesn't actually mean anything. This is a quote from that talk. Right? It's like, I'm a JavaScript programmer. I spend a lot of time trying to reason about why my program is not working. These are just problems that we encounter. And so much of functional programming and statically typed programming is about being able to sort of state definitively what is happening with your program. I think for me, the biggest thing to learn about Elm and to learn about programming generally is you're working with state and time and how those two things intersect. Here's another presentation by Rich Hickey, the creator of Clojure. He gave this presentation around the same time that both Elm and React came about. That's all about time with respect to state in a program. So you could think about Elm as this sort of on-ramp to purely functional, statically typed programming languages, if that's your thing. But for me, it's really about how do we think about state and time in a program. There's lots of really interesting approaches to this. Elm brings a perspective to other tooling like React, Redux, Angular, Ember, TypeScript, PureScript, whatever, that I think is refreshing and that I think helps me learn more about the entirety of the domain. And I think that's why you ought to look into it. I would be remiss in my duties if I didn't tell you that I work at Harry's and that we are hiring. And yes, I do realize that I have a beard. It's okay, everyone. It's all right. Follow me on Twitter. Subscribe to my tiny letter where I write about code. And I encourage you to just think about theory and practice together and what you can learn by just trying to learn more about the underpinnings and the history of the tools that you use. So thanks very much. I know I went a little over time. But...
Hello? Yeah.
Hi.
So after using Elm, how would you say that it measures up in terms of production readiness? Because I've heard from some people that it's not quite there yet.
I mean, I think it depends on what you're doing in production. I think for, personally, at Harry's, I would not put Elm in production. it's really nascent. The tooling specifically is really nascent. So time traveling debugger, awesome. The REPL is not very good. The language and libraries themselves are great. So it's like, I could see it maybe going into production for some sort of maybe admin interface. I think the integration with React is really interesting, where if you have a React app and you want one component to sort of be plugged in and use Elm for that, I think that's a really interesting use case that could be explored in production. But I think for the most part, there's a tooling story that is still being developed. Right? Elm is 0.18 is the version it is right now. And so I think it's still being worked out. Right? Like in 2 versions ago, it had this whole other FRP signal thing. So it's completely changed metaphors in that time. So it's something to keep in mind. But still worth exploring. You know? Production readiness. Your production is someone else's something else. I don't know. Yeah. Exactly. Cool.
Have you seen any benchmarks versus other languages?
Yeah. Actually, if you go to the Elm language blog, so part of like these benchmarking sort of wars between these is like all about virtual DOM implementations, which is like, I don't find personally like incredibly interesting, but Elm is really fast, especially when compared to things like React or some of these other virtual DOM kind of implementations. Ember's, I think Glimmer Engine is one of those. I think because of Elm's legacy, and Elm is built on top of Haskell, which has like, you know, an incredible type system and incredible compiler, it's able to sort of eke out a lot of gains in those areas. So it's on their website. Yeah. Yeah. So it's not an easy comparison to make, because Elm is really designed to be a web, like client-side web application framework. And you could do other things with it. Like there's ways to hook it into like Node, say, and stuff like that. But there really isn't like that kind of, it's hard to make that comparison. I would say Elm is easier to compare to things like, say, React or Angular or Ember, things like that, versus, say, Python or Node. Yeah. It's not to say there's not things out there, but that's the use case it's really aiming for, is the client side. Cool.
Mark, thank you very much.
Yeah, thank you.
That's outstanding.